Hey there, everybody. Welcome back. We are on our final video. We are doing 8.7. We're doing solving radical equations. And what pops up here is the Pythagorean formula or the Pythagorean theorem. Pythagoras was an ancient mathematician. I think Egypt. Don't quote me on it. And his theorem is about right triangles. A right triangle, two sides intersect in a perfect like square corner. And we label the sides A, B, and C, where A and B are called legs. The legs make the right angle. That's our right angle. C is called the hypotenuse. Pythagorean's formula is a squared plus b squared equals c squared. So if we solve this for any one of the letters, you will get c equals the square root of a squared plus b squared. Or if we do A, you have the square root of c squared minus b squared. Or B, square root of c squared minus a squared. Okay. So we're going to play find the missing side. First example, we will have sides of b equals 7, c equals 13. So if we do a little picture, we've got a, 7, and 13. A squared plus 7 squared equals 13 squared. A squared plus 49 equals 169. A squared equals 120. So we take the square root of both sides, and a equals the square root of 120, which is what? 120 is 4 times 30. That's 2 times 15, or I think that the 4 is the only thing that comes out, which is 2 root 30. All right, next example. One leg is 10 yards. The hypotenuse is square root of 120 yards. Well, we can call that A, and this is C. Hypotenuse is always C. So I've got 10 b and square root of 120. 10 squared plus b squared equals square root of 120 squared. And this is square root of 120 yards. Maybe I should put that in here. This is 10 yards squared. We got units there. So we got 100 yards squared plus b squared equals 120 yards squared. If I subtract 100 yards squared from both sides, I get b squared equals 20 yards squared. And when I take the square root of both sides, I get b equals the square root of 20. And the square root of yards squared is yards. And this ends up being 2 root 5. I don't know if I'm off camera here. There we go. And where does stuff like this come up? Here's a word problem for you, because we all love word problems. A computer monitor has a width of 13 inches and a height of 10 inches. I'm off the screen. What is the diagonal length? All right, we got a nice little monitor here. Maybe there's a little border around it. It's on a stand. It says the height here, the height of the screen part, which is where the actual screen is, that's 10 inches. And the width is this distance right here. And that's 13 inches. And they want to know the diagonal, which is here to here. What is that? Well, my picture doesn't look like it, but this should be a rectangle. So these are squares, square corners. So if I pull that out, this looks like 10, 13, and I don't know, we'll call that C. So 10 inches squared plus 13 inches squared equals C squared. I have 100 square inches plus 169 square inches equals C squared. This is 269 square inches. We'll take the square root of both sides. And C equals the square root of 269 inches. Now, I don't know how much that is, but I know square root of 269 is kind of meaningless to me. And I don't really want to factor it. So I'm just going to get a decimal. Where is my calculator? So C is approximately 16.4 inches. Oh, why does it matter? This, when they sell computer screens, they usually tell you the diagonal. This stuff comes up in real life. Other than that, that literally covers everything in Math 44. Do the homework, take the final, and you're done. Congratulations. I hope this has been a beneficial semester for you. Peace.